So write the problem once everybody, the problems on electric flux. Now the electric field in a region is given by E bar equal to alpha x I cap, where alpha is constant. At particular field, the electric field is there along x-axis only. Now we want to find the total flux passing through a cube bounded by surfaces. Total flux passing through a cube bounded by surfaces. X is equal to L and x is equal to L. Y equal to 0, y equal to L. Z is equal to 0, z is equal to L. The first bit is flux is finding. After that you will find what the charge also by using Gauss Law. Right, first you will find college will start maybe in the month of July, maybe. Now listen carefully. Now see the question here. Have you understand the question or not? The electric field is there along x-axis. The electric field in a region is given by E bar equal to alpha x k I cap, where alpha is constant. Now we want to find total flux passing through a cube bounded by surfaces. X is equal to L, x is equal to 2L. Y equal to 0 and y is equal to L. And z equal to 0 and z is equal to L. Now first we want to find the total flux passing through a given cube bounded by the surfaces. Now see that it's cube here. Okay, it's cube now. Now one side is at a distance L. One side, maybe our origin is here. This is origin. Here to here, this side, this face L this, and next face 2L. Understand? This face, if you draw this cube, so clearly so one face, now this origin, but we have taken, it should be like this here. So one face should be at L, x is equal to L, and the other face should be at x is equal to 2L, like this. The meaning is that. Okay. Similarly, y also, y for y 0 to L face, z also 0 to L, because cube is three-dimensional body, x, y, z. Okay. So here imagine this is origin. So here to the L, here to at this end 2L. Now we want to find the electric field in a region is given by E bar equal to alpha x I cap. So here E bar is not constant. Here E bar depends on what? X only. And E bar direction is what? I cap only. E bar direction is what? I cap. So now we want to find the total flux passing through a cube bounded by surfaces. X is equal to L, x is equal to 2L, y equal to 0, y equal to L, z is equal to 0, z is equal to L. That is the flux we want to find. So we know everybody the definition of the flux. Flux is nothing but what? Integral E bar dot ds bar. Yes or no? Flux is nothing but what? Integral E bar dot ds bar. So the field is also along x-axis. Field is always here along x-axis only there. So it's along x-axis. Now listen carefully. Listen carefully now. Here, this is a cube now. Now field is along x-axis. Field is along x-axis like this. Okay. Now this phase is there. Now lines of force is moving like this. Okay. So due to this phase, along x-axis phase, ds should be like this. E is x-axis, ds area vector negative x-axis, because area vector is perpendicular to the plane of the surface. And again the electric lines of force is going x-axis only. So E is I cap. For this phase, ds should be like this. Yes or no? So for this phase, top phase, E I cap, ds minus I cap. For the second phase, E I cap, ds also I cap. Okay. So due to first phase flux is there, but negative flux, entering flux always negative. Second phase also flux is there, emerging flux always positive, because EDS cos 0. Here EDS cos 180. I think we understand. Now coming to y, what happens now? If you're coming to y, then what happens? ds should be like this. Z also, ds should be like this, upper face. Z also, ds should be like this. But E is x-axis. Therefore, y, face y, this face, and back face does not contribute to flux. Why? Because EDS cos 90. Understood my point or not? EDS cos 90. Only which phase contributes? This phase only. This phase negative flux. This phase positive flux. And due to this phase, upper phase, because cube has 6 phases, due to upper phase, it's y. ds should be like this. But E is along x-axis only. EDS cos 90. Now if you take z phase also, this phase, E should be like this, ds should be like this. EDS cos 90. That's why which one only contributes electric flux? Only this one. Why? Because E also there along which axis? X-axis only. So the flux contributes, calculate here. Okay. Now simply entering, for entering flux, we know the flux equation, integral E bar dot ds bar. Imagine the phase AB, this phase. So E is already given, alpha x I cap dot ds bar, ds I cap, sorry, ds minus I cap. Okay, for phase 1, E is alpha x I cap, but ds is minus I cap, area. Therefore, you write the equation, I cap and I cap is 1. Therefore, integral alpha x ds, otherwise dx you write, alpha x dx. Sorry, dx is area, ds is area. So therefore, alpha is constant, integral ds is what? Area. But a total flux here, entering flux, otherwise you write simply ES only, otherwise total flux E bar dot S bar, you should write it. Otherwise you write ds, area of the first phase. So alpha x varies from where to where? 0 to L, first phase. Otherwise you write clearly. It should be at a distance of L. So otherwise entering flux you write like this better. Phi entering, simply E bar dot S bar. So simply write what? E and S 180 degrees. So cos 180. So minus ES. E is, you write what? X-axis only here. E is what? Electric field at a distance L. It depends on X only. Alpha L. S you write L square. Area of phase. Therefore, this is minus alpha L cube. Phi entering. So I am writing the phi entering here. So how can I write? It's I alpha x I cap, but S is negative x, negative x axis. Therefore, phi entering, you write what? Alpha ES cos 180. Now simply you write what? At a distance x, at a distance L, what is the phi E value? Alpha L. Area, S means area of the face, this area. This length clearly we know that L only, because already x is equal to 0 to x is equal to 2L. It's a cube only. So each side length is L only. Therefore, S is what? L square. Therefore, minus alpha L into L square minus alpha L cube. Next, calculate the flux at a distance 2L, leaving flux. Therefore, phi leaving. So phi leaving, how you write now? Same equation. E depends on alpha x. Here x is what? 2L from origin. So alpha into 2L. Again area is L square. Alpha 2L L square cos 0. Because E and ds both are same directions here. If you take the integration also, same thing we are getting. It's not a problem. If you take the integration also, we can the same thing we get it. Because here x depends on L here. This is origin, okay? L and a 2L. At a distance L, E is what? Alpha L. At a distance L, E is what? Alpha L. At a distance 2L, E is what? 2L. Because origin is this, imagine. At a distance L, at this face, E value is alpha L. Directly I am taking. Area is what? Area of the face is what? Side everybody we know, L. Because L, 2L. X is equal to L to X is equal to L. So side length is L only. Therefore, every side cube, that is, every side length is L only. So area how much here? L square. So how much of the contribution of the flux here? E alpha L into L square. Directly I am writing. Okay. This is a better way compared to writing the integration. Similarly, phi leaving. Phi leaving at a distance 2L. Now field is varying. Up to at a distance L, E is equal to alpha L. At a distance 2L, what the field value? E is equal to 2L. Okay. So alpha into 2L. Area L square into direction is what? Both are same direction. That's why cos 0. Therefore, what is the value of this one? 2 alpha L cube. It's a plus leaving. So entering flux is minus alpha L cube. Leaving flux is what? 2 alpha L cube. Okay. Now what is net flux? The first bit is what? Total flux passing through the cube bounded by the surfaces. X is equal to 0 to X is equal to 2L. Because it's due to this is 0. Y is equal to 0 to Y equal to 0. Z is equal to 0 to Z is equal to 0. Only this phase contributes electric flux. Because up to this first phase, the field is EL. Up to this second phase, the field is what? 2 alpha into 2L. Because here L square. So 2 alpha L cube. So therefore net flux, F net, first bit answer, minus alpha L cube plus 2 alpha L cube. Therefore, what is the value of this one here? Net flux is what? Alpha L cube. So the total flux passing through a cube bounded by surfaces, X is equal to 0, L to X is equal to 2L. How much here? 2 alpha L cube. Alpha L cube. Okay. It was simple way. Now next bit is charge finding. According to Gauss law, of electrostatics. So phi net equal to, we get alpha L cube. We know according to Gauss law, 1 by epsilon naught into charge enclosed is equal to alpha L cube. Therefore, is asking charge contained inside the cube. Therefore, charge contained, how much here? Epsilon naught, alpha L cube. Okay? For charge here, according to Gauss law, phi equal to what? 1 by epsilon naught, charge enclosed is equal to alpha L cube. Therefore, charge enclosed is equal to what? Epsilon naught alpha L cube. So this much of the charge is there inside the cube. In between x is equal to L to x is equal to 2L. Same model. I am taking what the electric field in a region is given by E bar. Have you understood everybody this model? So entering phase, listen carefully, x is equal to L. Imagine origin is here. L, next to L, end. Length is L. So side area is L square. Cube this is. Square this is. Square face this is. L square that is. Okay. So therefore, up to this, the field value EL, we know that. Up to this, the field value is what? Alpha into 2L. Okay. So phi entering is ES cos 180, so minus ES. Phi leaving is what? ES into S. That should be known. Now I am changing same problem. E, I am giving what? E naught x by L. Now changing the curves here. X is equal to 0 to x is equal to L. That means for this phase is at origin only. This phase is at origin. Find the value of flux and charge. So this phase the field is 0. Second phase only the field is phi entering is 0. Here phi entering, because E depends on x. Now we want to find x is equal to 0 to x is equal to L. So initially is what? 0 only, phi entering. Now phi leaving you should find. Because at x is equal to 0, E also 0. So here there is no field. First phase there is no field. Second phase you should find the field. Second phase x is equal to L means E naught only. So phi leaving. Phi leaving. E. E means E naught, because E naught into L by, because here x is L only, so E naught into L by L. E naught into L by L. L cancel you, so E naught. Field is E naught into area L square cos 0. EDS cos 0. ES cos 0. Therefore, phi leaving how much? E naught into L square. Therefore, total flux. So net flux how much here? 0 plus E naught L square. Therefore, E naught L square is a total flux. E naught L square epsilon naught E naught L square. Why phi entering 0? Because here surface bounds are changing. Because we have taken origin is here only. In previous case, origin is at L. Origin to first base distance is L. Now origin is here only. So x is equal to 0 means what E value here? 0. X is equal to L means what E value here? E naught into L by L. So E naught only. So leaving side only electric field is there. That means for leaving side only flux is there. Okay. So therefore E naught phi leaving E naught into L square, area is L side is L, so area is L square cos 0. So therefore E naught into L square. So the what is the value of flux, net flux 0 plus leaving flux is E naught L square, entering flux is 0, so total flux is what? E naught L square. Therefore 1 by epsilon naught into charge enclosed E naught L square. So charge enclosed is what? Epsilon naught E naught L square. It's a final value. Understand everybody? Any doubts are there? Understand or not? Have you understood the problem or not? Yes. Clear everybody? Right. Now next model on electric flux. Next problem number 2. A charge Q is uniformly distributed on a ring of radius A. A sphere of equal radius, A is constructed with its center at the periphery of the ring. Okay. Find electric flux passing through. Find electric flux passing through surface of sphere. A charge Q is uniformly distributed on a ring of radius R. Now, the ring is there. This radius is A. Its charge is given uniformly. It's distributed. Okay, the charge is given Q, total charge of the ring. Radius also A. A sphere of equal radius is A, is constructed with center at the periphery of the ring. Now imagine here O is center of ring. Okay, O is center of ring, but he is saying that what? Sphere center, a sphere of equal radius, is constructed with center At the periphery of the ring, center you will take at, imagine here, you take periphery of the ring. So now the sphere, now here this is a ring, circular ring. Now imagine the sphere like this. Okay. It's sphere. So this is a O dash. So O dash is what? Center of sphere at periphery of the ring. Okay. O dash is what? Center of sphere at periphery of the ring. For the diagram. So do you understand that? Sphere radius also A only. Sphere radius also A only. So sphere center at the periphery of the ring. Now we want to find the electric flux passing through the surface of sphere. Simple. Calculate once. Find the electric flux passing through surface of sphere. So if you want to find the electric flux passing through surface of sphere, simply we calculate first charge enclosed within spherical surface. Charge enclosed within surface of sphere. Find this. According to Gauss Law. What is charge enclosed? Yes, very good. Q by 3 epsilon. Nice. Now see here, everybody, by geometry of the diagram. This is A. Now it's center of ring. Center of ring to periphery of the ring also A, because radius has given A. Center of ring to periphery of the ring also A. Okay. Now center of O dash is center of sphere. Center of sphere to periphery of the sphere also A. Nothing but radius. So center of sphere to periphery of sphere is also A. Now this is A, this is A, this is A. So it forms what? Equilateral triangle. It forms what? Equilateral triangle. So at equilateral triangle, this is 60 degrees angle. This is also 60 degrees angle. Okay. Do you understand my point or not? Now my question is, so here it's making an angle at center of ring. It's making an angle center 120 degrees. And this is a arc, imagine like. Right? Now we want to find charge enclosed within the surface of sphere. So this is a sphere. Listen carefully. This is a sphere. So how much of the charge is there inside the sphere? This much of charge is there. This is A, B. A to B charge is there. You find this one. Okay, na? Understand the question or not? Now we want to find what is asking, find electric flux passing through surface of sphere. So electric flux passing through surface of sphere means what? 1 by epsilon naught into charge enclosed within surface of sphere. So we calculate how much of the charge is available inside the sphere. So inside the sphere, this is a sphere here. This is a sphere here. Inside the sphere, how much of the charge is there? A to B charge is present. Yes or no? Is it yes or no? Inside the sphere, how much of the charge is there? A to B charge is there. Ring charge. Actually, what is ring charge here? Q. So A to B charge is how much? You should find. Now angle here we know. Yes or no? 120 degrees. For 360 degrees. For 360 degrees, what is charge value? Q. That means entire ring. 360 degrees means what? Entire ring, the charge is what? Q. So for 120 degrees, what is charge here? 120 into Q by 360. Yes or no? Yes or no? For 360 degrees, the charge is what? Q. For 120 degrees, what is charge value? 120 into Q by 360. This is 3 times. What is charge value? Q by 3. Therefore, 1 by epsilon naught into Q by 3. What is the final answer here? Q by 3 epsilon naught. So the flux passing through the spherical surface, flux passing through spherical surface, how much here? Q by 3 epsilon naught. Flux is passing through the spherical surface. Understand or not understand? Again, logic understanding or everybody? Or any doubt is there? Have you understand the logic or any doubt is there? So here we calculated up to 360 degrees, what is charge here? Q. Now for 120 degrees, we want to find the charge. For 120 degrees, we want to find the charge that should be there inside the sphere only. Yes or no? So A to B charge we want to find. A to B, it's making an angle how much here? It's a ring. Listen carefully once. It's a ring. Charge is Q total. For 360 degrees, the charge is Q. So here it's making an angle A, it's B, it's making an angle 120. So for 120 degrees, what is the charge value? Q by 3. Because 360 degrees charge is Q. For 120 degrees charge is how much? 120 into Q by 360. Because 1 pen cost 10 rupees. What is 2 pen cost? 20. Why? Because 2 into 10 by 1. 2 into 10 by 1. So similarly, for 360 degrees charge is what? Q. For 120 degrees, what is charge? 120 into Q by 360. 123. Therefore, what is charge value? Q by 3. So therefore, 1 by epsilon naught into Q by 3. Okay, you should find like this. So go for the next problem. It's very important model. Understand this model? So it's a logical problem and good problem also. Next, a hemispherical body of radius r is placed in uniform electric field E. Uniform electric field E. The question is, what is the flux linked with curved surface? What is the flux linked with curved surface is first bit parallel to base, second bit perpendicular to base. Field is, what is the flux linked with curved surface is, flux linked with curved surface if is, if electric field is parallel to base and perpendicular to base. We know hemisphere, hemispherical bowl, its base here. So first case the field is like this. Its base. Second case the field should be like this. Perpendicular to base. First case parallel to base, second case perpendicular to base. Now, but is asking only flux passing through the curved surface. What is the flux linked with curved surface only? Base also we call plane surface. It's curved surface. Find the values. Let's go to here. Curved surface. So here, this hemispherical body consists of here two surfaces. Yes, one is curved, one is plane. Okay, field is along x-axis given. So we want to apply, if you apply the Gauss law, because here there is no charge. So it's a curved surface, the field is along x-axis. If you take Gauss law, net flux 1 by epsilon naught into charge enclosed within hemispherical body. Net flux is nothing but flux passing through plane, flux passing through curved is equal to 1 by epsilon naught into charge enclosed. Charge enclosed within hemispherical body 0. Therefore 5 plane plus 5 curved. phi plane plus phi curved is 0. Okay, so therefore phi curved I want to find is equal to minus flux due to plane. Therefore minus, what is flux due to plane? So E is E bar dot S bar simply. So here area vector, this is this plane surface, this area should be like this ds bar, okay, or S bar. Total plane surface we have taken S bar, so E should be like this, S should be like this. Therefore the angle between them is what? ES cos 90. What is cos 90? 0. Therefore in this situation, if the field is like this, flux due to curved surface how much here? 0. Okay, now coming to this. Now again, it's a plane surface, it's a curved surface. According to Gauss law, we know the formula phi net is equal to 1 by epsilon naught charge enclosed within hemispherical body. But charge enclosed within hemispherical body is 0. But net flux is nothing but phi curved plus phi plane equal to 0. But is asking phi curved only is asking. So phi curved is equal to minus phi plane. So here E is along x-axis, area vector is also along x-axis. Therefore you write minus ES cos 0, because area vector should be like this, perpendicular to the base. So E also like this, so ES cos 0. Therefore you write here minus ES, because it's a leaving flux. So E into S, area of plane surface. Plane is circle only, radius is R. So therefore E into pi r square. You write this. Okay, S is what? Area of bowl. Bowl area is what? Circle only. Just imagine, it's like hemispherical ball. So this is curved, upper one. Lower one is what? Plane surface only. It's a plane. Plane surface area is what? It's circle only, na? Hemispherical. So pi r square, that is. Because charge enclosed within hemispherical body is 0. Charge enclosed within hemispherical body is 0. What is charge on this? Any charge we have given? It's a hemisphere only. Imagine, it's a hemisphere. Who is asking? Mr. Soham, it's a hemisphere like this. Just imagine the bottle. Any charge is given here? Now we apply the Gauss law. Gauss law is what? Phi net is equal to 1 by epsilon naught into charge enclosed. Charge enclosed within what? Hemispherical body. Within hemispherical body, what charge value? 0 here. Therefore 1 by epsilon naught into 0. But phi is nothing but what? Phi net flux linked with the hemispherical body. That means net flux linked with curved surface, net flux linked with plane surface. Yes or no? Charges we are not giving. Yes. There is no charge. It's not charged hemispherical body. It's just neutral body. It's a neutral hemispherical body. That's why charge is 0. Next problem. Find the total flux associated with the surface as shown in figure. as shown in figure. Its cylinder, its radius is r. Okay. Now find just flux here. Field is also along x-axis. We are not giving any charge here. Find the total flux associated with the surfaces as shown in the figure. Because directly you can take it, net flux is equal to 1 by epsilon naught into q enclosed. So here q enclosed is how much here? 0. Charge enclosed within cylindrical surface is 0. It's cylinder this is. So flux is 0 we can say. Otherwise, we should calculate in another method. Here net flux is nothing but, okay? Net flux is nothing but, is asking the net flux only here. Phi, because curved surface having two plane surfaces, cylindrical surface having two plane surfaces, one curved surface. So therefore, phi plane plus phi plane plus phi curved equal to we want to find. So phi plane is first one. So field is along x-axis, but area vector is along this. So for first surface, ES cos 180. For second surface, field is along x-axis. Area vector is also along x-axis, second plane surface. ES cos 0. Next, curved surface. Now E is along x-axis. Area vector should be like this, S bar. Therefore, ES cos 90. Therefore, cos 180 is what? Minus 1. Cos 0, 1. Cos 0 is this. So like that also we can prove it. So net flux linked with the surface. Net flux linked with the cylindrical surface. Because cylindrical surface, cylinder has three surfaces. Two plane, one curved. Okay. So plane, here E along x-axis. So ES area vector should be like this. Area vector should be like this. But E is along x-axis. Area vector is like this. Negative x-axis. So ES cos 180. For this place, flux is there, leaving positive. So ES cos 0, it's a curved. So ES cos 90. So ES cos 400 minus ES, cos 0 plus ES, cos 90 is 0. So total value is what? 0. Like that we should calculate. Next one. A point charge Q is placed at the center of cubical box. The point charge Q is placed at the center of cubical box. Find first bit, the total flux associated with the box the total flux associated with box. Next one, flux emerging through each face of box. Flux emerging through each face of box. Next, flux through third bit shaded area of surface. Already charge is given, directly apply the Gauss law. Center of cubical box. First question. From this, you will find total 1 and 2 bit. For third bit, shade area. Now tell the answers first. The first thing is what? Here the Gaussian surface we imagine like cylindrical cube surface. Now here listen carefully. This is a cube. Okay, it has 6 faces. 1, 2, 3, 4, 5, 6. Now initially, first case, point charge Q is placed at the center of cubical box. Imagine at the center, the charge is placed. Then what is total flux associated with the box? According to Gauss law. According to Gauss law, the total flux associated with the box phi equal to what? We know that 1 by epsilon naught into charge enclosed within the cube. So 1 by epsilon naught into Q. Already explained the Gauss law also. Whatever may be the surface, the flux coming through the surface, total body, the flux coming through total body always equal to what? 1 by epsilon naught into Q. So if the charge is at the center, the flux coming through the total cube, nothing but all 6 faces. All 6 faces. How much here? 1 by epsilon naught into Q. Okay. So first question answer, the total flux associated with the cubical box is this. Next, second question. Flux emerging through each face of cube is asking only each face. So we know for 6 faces, okay, what is the flux is emerging? 1 by epsilon naught into Q. But he's asking one face only. So therefore 6 into one face, 1 by epsilon naught into Q. Therefore one face is asking the flux. Therefore for one face, the flux value is what? Q by 6 epsilon. Okay. For one face, what's the value of that? Q by 6 epsilon. Right? Now, so therefore second bit answer, flux emerging through each phase, single phase of the box, how much here? Q by 6 epsilon. So total flux associated with the box, 1 by epsilon naught into Q. and flux emerging through each face of the box q by 6 epsilon naught, because 6 faces, how much of the charge is coming out? 1 by epsilon naught q. For one face, 6 into one face q by 6 epsilon. Next, third bit. Now again charge is at center. Now flux coming through only this shaded area, nothing but one face. One face we know. Now listen carefully. For one face we know q by 6 epsilon naught. He is asking one fourth of the face. For one face, what the flux is coming? Q by 6 epsilon naught. Now the face is divided into 4 parts. Face divided into 4 parts. 1, 2, 3, 4. So now is asking flux coming through one part. So for one face, what is the flux value? Q by 6 epsilon naught. One face is divided for 4 parts, q by 6 epsilon naught, but is asking one part. So 4 into one part, q by 6 epsilon naught. So for one part, how much? Take 4 right side. So q by 6 epsilon naught, okay, by 4. Therefore, this value is what? Q by 6 into 4, 24. So 24 epsilon. So for one phase, this much of the charge is coming out. That means 4 parts, this much of charge, flux is coming out. So 4 part means 4 into 1 part, q by 6 epsilon. So for one part, what is the flux is coming? Q by 24 epsilon. It's increasing for one part. Okay, like that you should calculate. Write one note point. Write one note point. To calculate flux passing through open surface, not closed surface. Closed surface means we know directly 1 by epsilon naught into q. For example, if you want to calculate the flux passing through open surface, first make surface close. First make surface close in a manner in such a manner. To calculate the flux passing through open surface, first make surface close in such a manner that point charge comes at the center. Point charge comes at center. Point charge comes at center, and then apply symmetry concept. It's very, very important model. What's the model here? To calculate flux passing through open surface, it's not completely closed. First make surface close in such a manner that point charge comes at center. So always you should make it point charge should be at center for open surfaces, and then apply symmetry concept. For open surfaces, how can you solve the numericals? Now see the example, understand clearly. Based on this problem. At the problem here, a point charge q is placed. A point charge q is placed at the center of hemispherical surface. Okay. Find the flux of electric field due to this charge find the flux of electric field due to this charge q through the surface of hemisphere. Through the surface of hemisphere. Just it's a hemispherical ball. We place the charges like this. So a point charge q is placed at the center of hemispherical surface, so like this here. Now hemispherical surface find the flux of electric field due to this charge q through the surface of hemisphere. So how much of the charge is coming out? Because it's open one side, it's not full. So total, what is asking? Not its curved, not its plane. Is asking the flux of electric field due to this charge q through the surface of hemisphere. So when charge is placed, how much of the flux is coming out? Anybody? Tell the answer. So this is actually, it's not closed. Hemispherical surface what? Closed only. Here we place the charge. We place the charge at center of the hemispherical ball. Okay. Now we want to find the flux of electric field due to this charge through the surface of hemisphere. Okay. Now if you want to do this type of open surface problems, you use this concept. To calculate the flux passing through the open surface, first make surface close. First make surface close and make it what? Charge is at center. How can you make it? Imagine another spherical surface. Just imagine. Now exactly the charge is at center here. Now what is the flux passing through this total sphere? So flux passing through total sphere, we know that according to Gauss Law, you write here simply 1 by epsilon naught into q. Flux passing through total sphere in all directions. Electric lines of force is coming through all directions. How much here? 1 by epsilon naught into q. This total sphere we imagine 5 hemisphere. 5 hemi. 1 by epsilon naught into q. Therefore 2 into 5 hemi. Therefore 1 by epsilon naught into q. Therefore hemisphere flux through hemisphere, how much of the flux is coming? 1 by epsilon naught into q by 2. Therefore we write simply q by 2 epsilon. So this is very important. So to calculate this type of models, first of all we close the surface. Okay. You close the surface, you'll get what? Total sphere. According to Gauss Law, the total flux linked with the hemisphere sphere, total flux linked with the sphere This by total sphere, charge enclosed within the total sphere, 1 by epsilon naught into charge enclosed within the sphere. So flux is going. This I am writing here. So 2 into 5 me. So 5m is what? Q by 2 epsilon. It should be very important. Okay. So like that, we should go for shortcut. And same model. Next one, a point charge Q is placed. A point charge Q is placed at a distance a by 2. A point charge Q is placed at distance a by 2 above the center of. It's very important problem. A point charge Q is placed at a distance a by 2 above the center of horizontal square surface. Horizontal square surface of edge A. Now we want to find the flux of electric field. Find the flux of electric field through square surface. Find the flux of electric field through square surface. Say point charge Q is placed at a distance a by 2 above the center of horizontal square surface. Just imagine the horizontal square surface. A point charge Q is placed about this at a distance a by 2. Horizontal square surface means like this. It's square surface, otherwise we say that it's square surface. Okay, horizontal square surface. What is the edge of the horizontal square surface? A. From this we place a charge is here at this point at a distance a by 2. Okay. Now we should calculate the electric field through the square surface. So the electric flux through the square surface. It is also open. Surface is open only. Now how can you find it this? Now first make the surface close. First make surface close first of all. And charge we make it what at center only. So if you want to make it center, first make surface close by placing 5 square surfaces. Because square face is nothing but it's a one face of the cube. Square means one face of the cube. By placing 5 square surfaces or 5 square faces same side. So that a cube is formed. So from this we draw the cube. Because square surface or square face is nothing but one of the part of cube. Now, so from this is asking the question is what? Find the flux of electric field through square surface. Square surface nothing but what? Open. So if you want to make it open surface problems, flux, if you want to find flux passing through open surface, first we want to make it close. So first we make surface close and again make charges at center. Make surface close, at the same time charge also place at center. So for that purpose what we should do? By placing 5 square faces. By placing what? Above that, we place what? 5 square surfaces, so that what happens here? Cube is formed. So therefore, finally, if you take now this cube, then what happens now? Finally, it should be formed like this. If you imagine the five square faces, okay. So now it should be at center only. Actually, initially this is a square face. Now it should be at distance a by 2. Now imagine 5 square faces, then it forming what? Cube only. Okay. So for cube, for 6 faces, according to Gauss law, charge is coming what? 1 by epsilon naught into q. But one face is nothing but square face only. Square surface. You write what? Q by 6 epsilon. Okay. You should keep in mind. So whatever it may be, the open surface problems are there. First we make it what? Close. And make it charges at center. Then apply the Gauss law. Symmetry concept. What is Gauss law? According to Gauss law, 6 faces. What is charge value? Flux value? 1 by epsilon naught into q. For one square surface, what is the flux value? Q by 6 epsilon. It's a simple thing. But this point always should keep in mind. To calculate flux passing through open surface, first make surface close in such a manner that point charge comes at center, and then apply symmetry concept. Understand or not? Understand everybody? Yes? So this is an open surface problem, so we can solve like this here. Right, I will stop now class, and based on that, any problems is given in problems, you can go like this here. Okay, always you should keep in mind. And tomorrow also we'll continue the problems based on the electric flux only. Open surface. Clear everybody? So based on that, any problem is given. Flux is nothing but simply keep in mind integral E bar to ds bar, nothing but 1 by epsilon naught into charge enclosed within Gaussian surface. Here, whatever may be the surface, according to that, you will take it. Okay, right. Thank you very much.